Hey guys, welcome to the channel. If you're interested in automobiles and what's the news and what are the latest happenings in the automotive world, you must have noticed a major change in the design of the cars over the years. Other than for aesthetic looks, space requirements, ease of power transmission and legal regulations, there was a major factor which demanded all these changes in design. Well, we're talking about aerodynamics today. Before moving on to the topic, there is something that we should know first. A moving vehicle should overcome three major types of resistances. The resistances to the motion of the vehicle are air resistance, gradient resistance, and the rolling resistance. Gradient resistance occurs due to the weight of the vehicle. It acts parallel to the surface of the road in which the vehicle travels, and it is constant for all the speeds. The next one is the rolling resistance that occurs between the wheels and the road. It depends on the vehicle's speed and the road and tire characteristics. Then, the most important of all the three is the air resistance. This is the resistance offered by the air to the vehicle motion, and it depends on several factors like shape, size, and speed of the vehicle. But why do we have to learn all these? The design of the vehicle should be in such a way that it should help the vehicle overcome these resistances. A good aerodynamic design helps the vehicle in achieving the top speed, ensures better fuel economy, and provides better comfort to people. We know that air is a fluid and any object traveling in air experiences friction. The study of motion of air in relation to a moving object is known as aerodynamics. There are two aerodynamic forces that act on a vehicle. They are the drag force and the lift force. Drag is the resistance force that acts against the direction of vehicular motion. Drag force can be expressed using the formula given here. CD is the drag coefficient of the vehicle, ρ is the density of air, V is the speed of the vehicle, and A is the frontal area of the vehicle. From this, we can infer that the area, density, and drag coefficient being constants for a particular shape and condition, the drag force of a vehicle varies with its speed. At slow speeds, the drag will be lesser and it increases exponentially when the speed increases. Therefore, for achieving high speeds, the profile of the vehicle should be designed in such a way so that the drag can be reduced. This can be done by avoiding sharp edges, unwanted protrusions, and having the body well polished and more smooth. Now, let's see how these reduce drag by an example. You might have definitely played using paper rockets. But do you know why the tip of the rocket is always pointed? Well, the pointed tip has minimal contact area encountering air that tears the surface of air and it can easily travel in it. The same happens in cars as well. Air can easily move over sleek cars because of the curvy design, but it offers more resistance to boxy cars. Now let us take a box and sphere of the same frontal area. Even under similar conditions, the drag experienced by the two objects will be different. This is because of the shape of the object, which affects the drag coefficients. Therefore, the drag coefficient should be carefully considered while designing a vehicle. Now, let's discuss about lift force. Lift force is a vertical force component created due to the pressure difference between the top and bottom surfaces of the vehicle. Depending on the pressure difference, the vehicle can either be lifted or there can be a down force. The upward lift force will tend to lift the vehicle, and downward lift force, also known as down force, will help to increase the traction between the road and wheels. Down force plays a vital role, especially in race cars, as they require traction, especially during cornering and steering. Let's see how a race car acquires the necessary downforce. You might have noticed these objects on race cars. They are called wings. According to Bernoulli's law, fluid that moves slowly will have greater pressure than a fast-moving fluid. The wings are designed with higher surface area at the top when compared to its bottom. As the air flows over it, higher pressure will be developed at the top surface, whereas at the bottom there will be lesser pressure. This creates the necessary downforce. In addition to wings, splitters can also be used to improve downforce. So that's it for today, guys. We'll meet up in the next video. Until then, bye.